Right, so separation techniques. An ink is a mixture of coloured substances dissolved in water. So instantly, I'm thinking chromatography. Which method is used to separate the coloured substances in the ink? So chromatography, think colour, chroma means colour, graph means picture, so we get a colour picture. Chromatography is a separation technique that separates pigments in ink according to their mass. So the largest mass pigments in the ink mixture are deposited lower down on the paper, and the lightest, the smallest mass, are transported further up. So the answer to this question would be chromatography. Next, the apparatus shown in figure 6 can be used to separate water from ink. So this is distillation. Cold water flows through the condenser. On figure 6, use arrows to show where the water should flow in and where it should flow out. Okay, so what we've got here is we've got a mixture in here. So we've got ink and water, and distillation separates things according to their boiling point. So chromatography is according to their mass. All separation techniques exploit a specific property to separate a mixture. With distillation, it's boiling points. With chromatography, it's the mass of different chemicals. So we can assume that in here are two different liquids with two different boiling points, and what you really want to do is heat it up until you reach the boiling point of one but not the other. Or you can, so for example, if one had a boiling point of 70 degrees Celsius, the other one had a boiling point of 100 degrees Celsius, you'd want to reach a temperature in between these two values, but definitely not above or reaching 100. Why? Because if you reached 100, then both of these will evaporate. They'll both travel down the condenser and both be collected here. You want to separate them. So if you heated it to 70 or 75 or 89 or even 99, only this chemical will evaporate, leaving behind this chemical. That will go down the condenser, it will condense, and you'll get that here. So how this works is you heat up your mixture here to the desired temperature. You can check the temperature using a thermometer here. It vaporizes, it evaporates, and it basically, that's the first stage, it evaporates and the gas travels here. It's only got one way it can travel, down the condenser. Now, to turn it back into a liquid, we need to cool it down. And to help with that, to make it much quicker, what we do is we have a condenser. Now, a condenser basically, or sometimes called a Liebig condenser, what that has is water flowing through it on the outside here. Now, for that to happen, you may have seen this in a school lab. What we do is we connect this to a tap. So this will be, there's a rubber tubing here, and that'll be connected to a tap somewhere down here, and then water will come out over here into like a sink where it can drain off. So we have cold water running through. So the question says, on figure 6, use arrows to show where the water should flow in and where it should flow out. So we can have water flowing in through here and flowing out through here. So in, out, okay. So next it says explain why a condenser is used. Explain means tell me what a condenser does and the reason for it. So a condenser, as we talked about already, allows cool liquid to flow through, and the cool liquid will basically help turn back a hot gas into a liquid. So to cool the water vapor, or whatever it is that's evaporating, to cool it down so it turns back into a liquid. Easy. Next, it says the flask was heated with a Bunsen burner. Give the name of an alternative piece of apparatus that could be used to heat the flask. So you want something which reaches a very high temperature or a reasonably high temperature. So an electric heater would be a good one. That's what we use in a lab in class demos. A heating mantle, you could say, and a spirit burner. If you forget, an alternative to a Bunsen burner is a spirit burner, but the best thing is an electric heater. You just need to remember that. A water bath would not be suitable because it doesn't reach a high enough temperature. Obviously, if you put a water bath to 100 degrees, it evaporates itself. The particles in the ink in the flask can be shown as in figure 7. Particle of water here and particles of a coloured substance here. In the box below, draw the arrangement of particles that would be expected at A and B shown in figure 6. So if we go back here, A and B in figure 6. So